Dividing polynomials, we're going to use long division and then synthetic division to divide polynomials. Recall how to do long division. We take the divisor into a dividend, come up with a quotient and a remainder. So, in order to do long division, the first thing you do is write the dividend in standard form. And in this case, because there's no x term, I need to put a 0x in there, or our long division won't work out right. We write the division the same way we write dividing if it were numbers. And then we divide. So you look at this x and this x. And I need 3x squared, or 3x to the third, so I need 3x squared. And then you distribute. And you subtract. Subtracting there is the same as adding here, so we get 10x squared. Bring down. So I need 10x squared, so it's plus 10x. Subtract turns this to a plus. Now I need 20x. Subtract turns that to a plus. And so you write your answer, what you have at the top there, 3x squared plus 10x plus 20. The 50 is a plus, and that's the remainder over your divisor. So do long division. Again, make sure you're written in standard form. With your dividend. So your answer here would be 5x plus 1 minus 13 over 3x plus 1. This is x plus 8 minus 4 over x minus 3. You need to make sure it's in standard form so that your terms line up. And that your exponents. Okay, in synthetic division, it's a way of dividing, but we only use the coefficients. Again, it must be used standard form, zeros as a coefficient for any missing terms. And important part is that your divisor must be in an x minus a form. Then you put basically your A here, your coefficients, bring the first number down, we multiply and add. So it's a little bit different than long division where you subtracted. So I think it's best if we do an example. So this has to be written as x minus negative 1/2. So that my A is negative 1/2. And then we write our form, just box that out. Then coefficients. We have an x squared term, an x term, a constant. And then this number down here will be your remainder. So you bring the first one down, then multiply, add, multiply, add. So this would be, and then these are one exponent less. So this would be 4x minus 14 plus 16 over, and I'm going to write this in its original form. So I'll write that down here in this space. In the second example, you see that we're already in x minus, so my A is 3. Standard form, I have a 1 for an x to the 4th, negative 2x to the 3rd, no x squares, 3 at x, 1 constant. Bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add. One less exponent, so this would be x to the 3rd plus x squared is 3x plus 12 plus 37 over x minus 3. So try these. Show your A. It says it's x minus, so your A is negative 3. X squared, x constant. Bring down, multiply, add, multiply, add. Again, x minus a, so my a is 6. Terms go 1, negative 3, negative 18. Bring down, multiply, add, multiply, add. So in this case, I have a 0 remainder, which means I won't have a number over top of that divisor. So this will just strictly be x plus 3. And how do you include the terms with the 0 coefficients? You put them in standard form. Decreasing exponential order. How do you recognize the quotient and the remainder? The quotient is the numbers. Remainder in the box is the last number or in the box. Okay, that is day 1. So go ahead and practice.